Welcome, first secondary students, to today's explainer. I am absolutely thrilled to be your guide today, mostly because we're jumping straight into one of the most crucial, mind-bending, and honestly, genuinely fun parts of your October mathematics syllabus. Seriously, today we're going to look at a concept that just completely breaks the rules of traditional math and introduces this unstoppable new duo. We are, of course, talking about complex numbers. So grab your notebooks, get comfortable, and let's get ready to totally level up your algebra game.
Okay, so let's kick things off with a seemingly simple equation. X squared plus 1 equals 0. Now, if you try to isolate x, you move that 1 over to the other side, right? And you get x squared equals negative 1. And bam! This right here sets up the ultimate math conflict, because up until now, in literally everything you've ever learned, traditional numbers hit a massive, completely unbreakable wall right at this exact spot. To figure out why, let's bring in our first character in today's story. The real part. You can think of the real part as this smooth, structured, incredibly sensible character. He basically represents all the everyday numbers you already know and love, like 5, -3, or even your standard fractions. But when faced with x equals the square root of -1, the real part completely fails. He is totally stumped. And I mean, that makes sense, doesn't it? Because no matter what real number you multiply by itself, whether it's positive or negative, the result is always positive. You literally cannot find the square root of a negative number using everyday math. But right when the real part is ready to throw in the towel, our 8-bit pixelated hero makes a dramatic entrance. The imaginary part swoops in to save the day, and this character brings a virtual, magical, totally rule-bending tool to the table, the imaginary unit, which we just call I. By definition, this incredible little unit states that I squared equals -1. It was actually invented specifically to solve those impossible equations with negative square roots. Thanks to I, what was completely impossible suddenly becomes totally solvable.
All right, let's dive into Section 1, the superpowers of I.
Let's talk about exactly how this quirky virtual number operates. The really cool thing here is the cyclical nature of I's powers. It's kind of like the imaginary part is constantly shapeshifting through these 4 exact stages. We start with I to the power of 1, which is, well, just I. Then there's I squared, which we just learned is our magical -1. Multiply by I again for I to the power of 3, and you end up with -I. Finally, I to the power of 4 brings us all the way back to +1. And after that, the cycle just repeats itself endlessly. It's this perfect loop of 4. So the crucial takeaway here, and honestly, this is your powerful cheat code for those October exams, is that since the powers repeat every 4 steps, you can simplify literally any power of I, no matter how huge it is, just by dividing the exponent by 4. If it divides evenly with a remainder of 0, boom, the answer is 1. If you punch it into a calculator and get a decimal of 0.25, which means a remainder of 1, the answer is I. A decimal of 0.5 gives you -1, and 0.75 gives you -I. So let's say you have I to the power of 20. Well, 20 divided by 4 is exactly 5, with 0 remainder. So the answer is just 1. See? It really is that easy.
Moving right along to Section 2, the ultimate team-up.
Let's contrast these two unique styles for a second. On one hand, we have the sensible, super familiar nature of A, our real part. On the other hand, we have the wild, rule-bending reality of B, our imaginary part. They seem like total opposites, right? Like they represent entirely different mathematical worlds. But actually, this exact contrast is setting the stage for their legendary partnership.
Witness the birth of the complex number, which we call Z. By combining A and BI together with a simple plus sign, both of these characters unite to form a perfectly balanced math team. This right here is the standard form of a complex number, Z equals A plus BI. Basically, every complex number in the universe is just this amazing buddy cop duo working together in a single package. But how do these teams actually interact with each other? Well, when you set 2 complex numbers equal to each other, like A plus BI equals C plus DI, you just have to remember one golden rule. Real parts only talk to real parts, and imaginary parts only talk to imaginary parts. It's almost like they speak 2 entirely different languages. So for the whole equation to be true, the real number A has to be exactly equal to C, and the imaginary coefficient B has to be exactly equal to D. You can use this simple matching trick to solve all sorts of wild variables on your exams.
And that brings us to Section 3, complex operations.
It is time for the final boss battle, where we test our new duo against actual algebraic operations. For addition and subtraction, it's just like equality. You simply group your like terms. Add the real numbers together, then add the imaginary numbers together. Super simple, right? Now multiplication, that's where things get a bit spicy. You use distribution or the FOIL method, just exactly like you would with regular variables. But here's the absolute critical difference. Whenever I squares up in multiplication to become I squared, it magically transforms back into a -1. This totally flips the sign of that term and turns it straight back into a real part. It's this brilliant mid-battle transformation that you have to watch out for.
Finally, we've got to introduce the conjugate. Think of this as the duo's ultimate finishing move. The conjugate of a plus bi is simply a minus bi. Literally, you just flip the sign of the imaginary part right in the middle. We use this move mostly for division. Why, you ask? Because when you multiply a complex number by its conjugate, the imaginary middle terms completely cancel each other out, and that I squared pops up again to turn negative. The whole thing satisfyingly resolves straight back into a pure, stable, real number, a squared plus b squared. Absolutely no imaginary parts left, just a super clean, totally solvable fraction.
And there you have it, folks. What started out as a completely impossible math problem was solved by the ultimate team-up between the structured real part and the reality-bending imaginary part. You now know their powers, their specific rules, and their ultimate finishing moves. So, I guess my final question to you is, how are you going to use this unstoppable A plus B I team to absolutely conquer those impossible questions on your October exams? You have all the tools you need right now. Keep practicing, trust the logic, and go ace those tests.